start our last unit of the year. Can you believe it? Our unit is called polars, and we are going to start with polar coordinates. Polars is a different kind of graphing, a different way to define coordinates and equations that you deal with in normal what we call Cartesian or the XY plane. And we are going to move to a different system, if you will. And the purpose of that is because sometimes the math that we want to do in function world, especially when we really want a function but we don't have a function. We have a vertical line, or we have a circle, or we have a function but it's not one-to-one, so messing with the inverse is tough. And so we want to be able to use our function rules. Sometimes transforming to a different system is a way around those obstacles in rectangular or Cartesian land. So I happened to be, with this COVID, I was going to go to Mr. Getz and I were going to go to a concert, and I had my ticket stub, and look, can't go. And I was going to go to Unit 11, Polar Functions and Complex Numbers. What now? Anywho, your homework is in the book, page 539, 3 through 30, every third, right? So do 3, then 6, then 9. If you want extra practice, do more in between. All right. Oh, look at my polar. When people say polar coordinates to me, I think about the North and South Pole and being super cold. So the polar grid, or the polar graph, looks like that. Whoa! Check that out. Now on Canvas, I have a handout with a whole bunch of these blank graphs like this. Okay, it's got 6 on one page, so you can print them out if you want to go ahead and if you want to pause and print out while so you can use it while you're taking notes. Well, wait, Dylan doesn't take notes, but hopefully some of you do. All right, so the polar graph does have what we call a pole, and the pole is at the center. Kind of sort of think of it as the origin. There's also the polar axis. The polar axis is horizontal. We call this the positive polar axis, and the negative polar axis is here. We don't have the traditional Cartesian, right? Horizontal and vertical. We just have the pole. From the pole, right? The pole again is this center, this point, which is really called the degenerate circle. I don't know if you remember that from conics and AAF, but the degenerate circle with a radius of 0 is a point. That's the pole. Notice the concentric circles radiating out from the pole. Okay, so each one of these has a radius. This circle, for instance, has a radius of 1. Right? This radius, as you radiate out from the pole, this ray at 5 pi over 12 intersects first the circle with a radius of 1, then a circle with a radius of 2, then a circle with a radius of 3, then a circle with a radius of 4, then a circle with a radius of 5, and of course it could keep going and going and going. So the polar grid, how you plot points on a polar grid are not x comma y. They're radius, which one of those concentric circles, right, are you going to use, and then which theta are you rotating to. And remember from our trig and from parametrics and all that, when you, right, in standard position, you are always, and that's why I only drew the positive polar axis here, theta is always measured in the counterclockwise direction to be positive, and if theta is negative, you're going in the negative direction. So a radius and a theta, the radius tells you which circle, and then theta tells you how far to rotate. Okay, so the radius of a concentric circle and then rotate around that circle is your theta. If you have a negative radius, right, a negative radius means instead of going to the right, you go to the left and then rotate. So, naming a point. R comma theta, here's our axes, or our grid, and there is a point on the axes. So we're going to name that point R comma theta. So can you tell which circle, which one of those concentric circles is it on? Right? It's the one with the radius of right? Here's our pole. So this is the radius of 1, radius of 2, radius of 3. But that's in the negative r direction, right? So I need to know I was on this circle, so I'm going to go out 1, radius 2, radius 3, and then how far do I radiate in the positive direction? Rotate in the positive direction. So that is out to the circle with a radius of 3, rotate from standard position 5 pi over 6, right? Which is just shy of 1/6 shy of pi, right? That's the name of that point. But here's the cool thing about polar coordinates. I could name this point a lot of different things. Can you guess? Look at that. 3 negative. So the 3 is positive, so again you have to go 1, 2, 3. But then instead of rotating in the positive theta direction, you're going to rotate 7 pi over 6 in the negative direction. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and 7 pi over 6. And of course, in the wrong direction. Again, remember in AAF when the very first worksheet we gave you was doing coterminal angles and spinning around and spinning in the right, spinning to the left. Right? There's a reason we make you do these things. Can you think of another name for this point? Okay, what does this mean? This means go 1, 2, out to the third concentric circle, but to the left, and then travel in which way? Right? Travel in the correct way, right? And the correct way is counterclockwise, 11 pi over 6s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. What else could I do? Right? That, I think, would have probably been simplest. Don't you? That would have taken the least amount of drawing. Radius negative, so go left, 1, 2, 3. Rotate in the wrong direction, which means clockwise, 1 pi over 6. Okay? So not so bad, right? Plotting points. So look at these directions. Give all possible coordinates for this point. And this is r comma theta. So the first thing I want you to do is to draw that point. So with a radius of 4, you're going to go out positive 4, so that's to the right. Go to the fourth circle, 1, 2, 3, 4, and then go all the way around. to 11 pi over 6, which is just shy of 2 pi, right? There is that point. But notice that that point, couldn't I land here and then just add what? Add how much? 2 pi and land at the same place. How much? What else could I add? Right? 4 pi and 5 pi. So a way to give all possible coordinates is to say 4, the radius doesn't change, the radius was constant, 11 pi over 6 plus 2 pi n, right? 1 pi over 2, 2 pi over 2, 3 pi over 2, negative 1 pi over 2, negative 3 pi over 2. I'm sorry, negative 2 pi, right? But what else could you do? Is there something else? That's actually not all of them. That's going out to 4, spinning around to 11 pi over 6, and then either adding 2 pi n or subtracting 2 pi n. What else could I do, though? Couldn't I go 1, 2, 3, 4? There. What is that? How many pi over 6s did I go from the negative? Right? 1, 2, 3, 4, 5. Yeah? Uh-huh. Right? And that way you could, she wants you to do the oven to 350. Preheat, please. Right? I could land here. I could say negative 4, 5 pi over 6, and then add 2 pi to that. Or add 2 pi times 2 would be 4 pi to that, or 6 pi to that. But I could also go this way, right? Right, and that would be making n negative 1 or negative 2. Okay, so not so bad. Notice what's different about these directions. I want you to talk to me in degrees, so pay attention to the directions. Do they want you to talk to them in degrees or radians? I know I have my radians listed around here, but I'm asking to give all polar coordinates for A, B, C, D. So maybe again you want to pause the video and see if you can do this yourself. And see if you can name them. Positive radius 2. Rotate how many degrees? Pi over 6 is 30 degrees. Now I only want to stay between negative 360 and 360, so I'm not going to add 360 to that because then I'd be past 360. So what else can I do? Can't I go positive 2 and then go in this direction? How far is that? $330 degrees, isn't it? But which direction? Good. Now can you give me, what about if my radius is negative? Right, if my radius is negative, it would be -2. And then I could travel in the positive theta direction or the negative theta direction. Mm-hmm. And this is what I got. So again, I'll just write down what I had, the 4 that I got for all these other ones. B is on the circle of radius 1. So you can go to the right, or rotate in the positive, rotate in the negative. C was also, just like A, on the circle of radius 2. And D is on the circle with a radius of 3. Fourth quadrant, right? So each one of these has to be in the fourth quadrant. -45 degrees. Starting at a radius of -3, I had to rotate 135 degrees in the counterclockwise direction, or -45 degrees. Whoops, sorry. -225 degrees in the clockwise direction. So this hyperlink here takes you to a site where you can practice. So if you look at this on this GeoGebra site, right, it lets you plug in a radius and a theta, and it's in radians. So, and then you take the slider. So for instance, this was a radius of 1, and let's make theta pi divided by 4. Shocker, that's what that was. And then watch when you hit the slider. So the slider rotates theta first from the polar axis and then shows you the radius. Okay. Let's do another one with a bigger radius. Let's do a radius of 3, and let's keep theta at pi over 4 and do the slider. So see, it's going to radiate pi over 4 and then out to the third circle. So let's put in one of those points from the slide that we just did. For instance, let's put in for point C. C had a radius of 2, and it was at, what, 4 pi over 3, I think? Was it in the third quadrant? I'm trying to remember. Third quadrant, so 4 pi over 3, I think. So notice again that it's going to radiate from the pole and the counter from the polar axis, positive polar axis there, and then out becomes the radius to the circle 2. Right, and I think that's what we had, if I'm reading my notes correctly. But, so look at where that point is. What happens if I change the radius to -2? Right, that's not the same place. But remember, we had -2 and pi divided by 3. Oh snap, that's the same location. Right, so you can play around with this applet if you ever want to check the points that you've been drawing. So what if, now look at this question. Use the table to help graph your radius is equal to 3 times secant of theta. What the heck does this mean? So remember, I alluded to the fact that we're in a different system, right? But we still have an independent and dependent, right? Independent. All right, back to AAF, right? What's independent? What's dependent? Independent, dependent. So choose your theta, and that's why the applet always did the theta first, right? Because you put in a theta and that generates your radius, right? If somebody just gives me a point to plot, I generally use the radius and then rotate. And it is kind of weird that theta is independent and r is dependent, and yet the coordinates are r comma theta, right? We're just not, that's just the rules of polar land, okay? So look at here's all my choices for theta. And remember, 3 secant theta is really 3 divided by cosine theta. So look at let's complete the table. When you put in 0, cosine of 0, right? Speed trig, remember? Cosine of 0 is 1. Right, so 3 divided by 1 is 3. Cosine of pi over 4 is 1 over root 2. Do the reciprocal, which is root 2, times 3. Cosine of pi over 2 is 0. 3 divided by 0 is undefined. Cosine of pi over 4 is 1 over root 2, but 3 pi over 4 is in the second quadrant. Cosine is negative, and cosine is in the denominator, so I'm going to reciprocate, and so on and so forth. This is why you do speed trig. Right? You can't be taken forever to do and calculate. Right? 7 pi over 4 is in the fourth quadrant. Cosine is positive in the fourth quadrant. Now look at what happens when I plot these points. When I plot these points, again, I tend to go to the radius first. So I'm going to go out to a radius of 3, 1, 2, 3, and rotate nowhere. Then I'm going to go out a radius of 3 root 2, and if you hit your calculator, 3 root 2 is a little bit, I wrote it down, I think it's like 4-ish, 4.3. I have my calculator right here. I don't know why I'm trying to read my small notes. Right, if you type 3 square root of 2, you get 4.2. So I'm going out to a radius of 4.2. 1, 2, 3, 4, and a little bit. And I'm rotating to pi over 4. One, 2, 3, 4, right? Then I don't graph anything at pi over, I have no radius to go pi over 2. But now I go to a negative radius, -3, 1, 2, 3, times root 2, so it's actually 4 and a little bit. And I rotate in the counterclockwise direction, 3 pi over 4, which is going to land me here. Then I don't graph anything. Then I also go to negative 3 pi over 4. I'm sorry, negative 3 root 2. And then I go 5 pi over 4, which is here, here. Oh, that's this point. Right, so I graph this point, there's nothing to graph here, I graph this point, and I landed on top of a point I'd already graphed. I graphed this point, I went to positive 3 root 2, which again is 4.2-ish, and rotated 7 pi over 4. Oh my goodness, I landed at this point. I think I see a pattern. Gee, what kind of pattern is this? OMG, it's a vertical line. Vertical lines in function land aren't functions. But look at this equation that generated a vertical line. What? Right? That's crazy. Now I want you to go get your calculator. And I want you to go to mode and hit polar mode. So mode, polar. Go to y equals and look at how it's changed. R is equal to what? 3, there's no secant button, cosine x. Oh, snap it, type the theta. Don't hit graph, please. I want you to go not to window, I'm sorry, I want you to go to second zoom, which is format, and I want you to change from rectangular coordinates to polar coordinates. And now I want you to hit zoom 7, which is zoom trig. You're in radian mode, so it's going to set the window to negative 2 pi to 2 pi. Oh my gosh, look at what I just graphed. A vertical line. Hit trace. When the radius is equal to 3, theta was 0. Pi divided by 4. Remember, remember when you hit trace, you're going to get the independent variable, right? The independent variable is theta. So you enter pi over 4, and look at that radius. 4.2-ish. That's radical 3 times 2. Right? Crazy. Sorry, 3 times radical 2. All right, let's try 7 pi divided by 4. Oh, snap. I'm down there. Let's hit 5 pi divided by 4. Whoops. Look at my radius. My radius is negative 3 root 2. But obviously, there's a whole lot of points on this vertical line that all came from an equation. The radius is equal to 3 divided by cosine theta. Wow. Now again, notice that if you hit second format and you hit rectangular coordinates again, look what happens when you hit graph. Nothing. Except if you hit trace. Look what happens if you hit trace. I still enter the theta, pi divided by 4, but notice I don't get the radius. I get the x and y coordinate. Say, what? All right, let's see if we can figure out what's going on. Remember, I talked at the beginning about going back and forth between, between polar mode and rectangular mode. So what if, reaching back into your memory banks, what we did with, right? Remember, do you remember writing the vector form of a line? Look at those formulas. Don't they look familiar? So converting polar back to our normal regular rectangular. The polar coordinates r comma theta can be transformed back into rectangular coordinates by using triangle trig. Triangle trig, right? X is equal to the radius times cosine of theta, and y is equal to r times the sine of theta. So look at this problem here. Find the rectangular coordinates for 4 comma 2 pi over 3. Well, let's first get an idea of where 4 2 pi over 3 is. Now I'm going to go ahead and draw a rectangular graph because I'm going to rectangular, but I'm going to plot the point as if I'm in polars. I'm going to go out to the concentric circle with a radius of 4, and I'm going to travel in the counterclockwise direction around that circle (2 pi over 3). So this point is in polars 4 2 pi over 3. I went out 4 and rotated 2 pi over 3 radians, and I got right here. But I want to know what that same point in rectangular land, what are its coordinates? So let's use, I hope you expect a negative x and a positive y, right? So what do we get here? X is equal to my radius times cosine of theta. Cosine of 2 pi over 3 is what? Certainly negative because you're in the second quadrant. So isn't that negative 1/2? Meaning this is negative 2. What about my y coordinate? Sine of 2 pi over 3 is positive and is 2 root 3. So this is negative 2 root 3. In rectangular form, over an x, up a y is a right triangle, right? Where the distance you traveled here was 2. The distance you traveled here was 2 root 3. Gee, I wonder what this distance is. Come on in, Pythagoras. Come on in. Gee, how can I find that hypotenuse? X squared plus y squared, take the square root of, wait, what? So the hypotenuse of that right triangle is the same as my radius in polars. OMG. It all comes together now, doesn't it? Crazy. All right, here's one for you to try. I'm almost done. Give the rectangular coordinates for this one. Now notice this arc was special. You're supposed to know that from trig, right? Speed, trig, unit circle, all that. You also need to recognize this is not special. So this one you need to know. This one you can use your calculator for. So the rectangular coordinates are Make sure you're in radian mode. Think about what quadrant 2/5 pi is in, right? 2/5, 1/5, right? 1/5 would be not very high, right? So -4, so I'm going out a radius -4, -4 to here, and then I'm traveling in the counterclockwise direction, right? I'm in the correct way, 2/5 pi. So when I was done with this, I typed this into my calculator, right? 2/5 pi is actually in the first quadrant, so cosine and sine are both going to be positive, but you're going to multiply times -4, and you're going to get a negative. So -4 cosine 2 pi divided by 5, -1.23-ish, and -4 sine 2 pi over 5 is -3.8-ish. Cool? Right, so if you are one of our special unit circle values, you are supposed to know those exact values. If not, use your calculator. All right, let's go the other way. You should recognize this, right? That's the hypotenuse, which is the radius from the pole of the rectangular coordinates. And then how do you find theta? Theta is inverse tangent of y over x. Be careful. You always have to think about what quadrant you're in. Remember that objective from AAF? What quadrant are you in? Be careful. So look at this question. Give the polar coordinates for 4, -7 that satisfy the following conditions. So the first thing I'm going to do is draw this. This is rectangular form. This is rectangular. X comma y, 4, -7. I'm in the fourth quadrant. So what are the coordinates that land me at that point, but my theta is between 0 and 2 pi? So firstly, I need to know I'm in radians, not degrees. So I'm going to say, well, my radius is the square root of x squared plus y squared. I don't care about the negative because I'm going to square it. This is approximately 8 something little, right? Because 64 is exactly 8. 0.01 maybe, or 8.1 maybe. I think that's what my calculator said. Check it out. Yeah, well, 8.06, so 8.1 is fine. I really just need the square root of 65. But now, notice when I do theta, theta is inverse tangent of y over x. But you have to remember that's not a special value. My calculator is going to, you have to know the domain of inverse tangent, which your calculator is programmed with. So when you do inverse tangent of -7 divided by 4, you get -1.05. But you have to know inverse tangent is only giving you values in quadrant 1 if you have a positive value, or quadrant 4 if you are in, right, if you have a negative tangent. So I think to myself, well, this is cool. Quadrant 4, cool, right? But what did my directions say? My directions say I wanted polar coordinates where my theta was in between 0 and 2 pi. So what do I have to do? So these polar coordinates are, r is the square root of 65, right? So that's going out to a radius of 8-ish, and then spinning around how far? Well, I know negative 1.05 radians is this far, right? So what are you going to do? That's right. You're going to do 2 pi minus that. So I got square root of 65 and 2.09. All right? How else could I get there? Right? How could I get to the same place with radiuses? Couldn't I do negative root 65? If I did negative, but again I have to have a positive, I have my rotation has to be between 0 and 2 pi. If I go out here to negative root 65, right, negative radius, and I want to travel in the counterclockwise direction, how far is this? Okay. Negative, go to here, right? How far is that? So each one of these you have to realize where I'm at, and for each one of these problems you have to figure out how far I am, right? So this is pi, so I have to do pi minus the 1.05. So pi minus, oh sorry, that is my 2.09. Oh, did I mess up? This is the negative and the other's the positive. Sorry, this is negative 5.23 is the positive. Sorry about that. So what if they ask you about 0 to 4 pi? What are you going to do with each one of these answers? Can't you just add 2 pi to these two answers and you've taken care of this scenario? But what about this scenario? My theta has to be between 0 and 3.14. Well, this one takes care of it. Right? So all these different problems, you have a problem like this in your book, all these problems are asking you to do is to figure out different ways to spin. If you have any restrictions on what theta is, just how do I spin from my radius? Remember, your radius will not change, right? Your radius is going to be constant. How do I spin there? Positive, right? Do I go in the counterclockwise or clockwise direction? Does my theta have to be always positive? Does my theta have to be negative? You know, all that kind of stuff. Right? All right, my dinner's ready, so I gotta go, but I think you got it. I hope you have a good rest of your day, and I will see you another day.